presentation is like on volleyball as well. Just as Kruger had said, I'm Kayla Hall.
I'm Sophia Wilson. And the history of volleyball. The definition of the game is a game for two teams, normally 6 players on each team, where a ball is hit by hand over a net with the objective of making the ball hit the ground on the other side of the net. And in 1895, a YMCA instructor named William G. Morgan created the game of volleyball by blending the elements of basketball, baseball, tennis, and handball. And his objective was to create a sport that his businessmen could do. Like, he had classes of businessmen and they didn't like a lot of physical activity and to get sweaty and all that stuff. So he wanted less physical contact for them. And in 1896, the first game was played, and it was July 7th at Springfield College. And in 1964, it was introduced to the Olympics in Tokyo.
So parabolas. There's parabolas all throughout the game of volleyball. It's involved in your set, in your pass, in any type of hit you have, on your serve. It's basically a really key part in the game of volleyball itself. So you have right here is the equation for a parabola, the y equals, in this case it's negative x squared because it is a concave down, this way, concave down parabola when you're talking about setting specifically. So the axis of symmetry is very important as well. This is the line that runs down the center and divides it into 2 perfect halves. You'll see in any of these sets, the axis of symmetry is going to be right in the middle, and you're going to want to line it up directly so it's half in between your setter and the point of contact. Not the point of the approach, not the point of where the ball is actually going to be placed or where it would drop if it wasn't actually hit across the net, but the point of contact. So for the 5 set, you're here. The 4 set, further out. 31, closer to the center. So the axis of symmetry and the vertex of that set is really key in any type of play. So as the setter moves forward or backward, there's a vertical stretch or a vertical compression. So this basically says that as the setter, say they move forward and they're still setting that 5 set, there's going to be a vertical stretch because the height of the vertex still has to increase for the ball to get to the point of contact where it originally was going to be. Now if the setter moves back and it still is trying to get the 5 set, it's going to be a vertical compression because the height of the set doesn't have to be as high to get to that point, but it does have to travel further distance. So that also brings up the point of timing. So your timing is key as well because every set's not going to be the same. So as the set comes from the setter's hands, the hitter has to approach the specific timing in order to hit the ball at the highest point when they can reach it at the highest point as well. So that's also, timing is really key in volleyball as well. This just kind of goes over everything as we, once again, kind of with more pictures. Right here you'll see the axis of symmetry and the height of the very highest point in the set. And the same equations as well shown on this slide. So not only is there the vertical compression and stretch, you also have the vertical translation when you involve jump set versus approach set. So jump set is just what it sounds like. The volleyball player is going to jump as they set the ball, so their point of the set will increase. So you'll see the equation y equals negative x minus 2 squared. And then the crouch set, when they drop down, I don't have a picture of that as on this screen, but they'll crouch down, so the point of their set is going to decrease on the y-axis if you drive in there. So then that equation as well is going to be y equals negative x plus 2 squared. And what I mentioned before, that was simply vertical horizontal translation as you're moving across the net back and forth. And we have a couple example equations, which got cut off on the screen, but just on the bottom there as well. And then we have a video.
The the lift, which is a formula for lift force. And lift force increases as the ball rotates faster, and as the ball slows down or stops, that's when it decreases or goes to zero. And the equation shows the manipulation of different characteristics needed to figure out the lift force. So like F equals the force, velocity, cross-sectional area of the cylinder, and the lift coefficient for the density.
Here's just a video explaining further. I'll give you a mental picture as well.
So yeah, I think we're good. I think that about wraps it up. So
Great, I'll send a follow-up email.
there's nothing.
So I'm back at the University of Sydney with Rod Cross.
Hi, Derek.
And today we're talking about the effects of air on projectiles.
We are.
Now normally we neglect these effects. When I'm teaching students about projectiles, I tell them, forget about the air, let's just talk about gravity.
Because it simplifies the problem. But air is real, it's heavy stuff, and it affects the flight of all projectiles.
Alright, well why don't we do a little experiment to show the effect that air can have.
This is a surprising experiment that we've set up here. First of all, I'll show you what happens to a tennis ball when it rolls down this inclined ramp.
Well, that follows exactly like I would expect, basically a parabolic path.
As predicted, but let's try something a little bit lighter, such as this paper cylinder.
Okay.
Weighs only a gram or so. The effect of the air will be more important. Watch what happens this time.
Okay. Whoa! So the paper cylinder goes backwards. That doesn't make any sense. I mean, it was rolling forwards off that ramp.
No, it does it every time, and it's because of an effect known as the Magnus forces acting on the spinning cylinder, acts on.
So yeah, it just kind of goes in further what we already mentioned. Alright, so next comes the float serve. So we mentioned topspin before, topspin serve. The next is the float serve. Now this, in my opinion, and a lot of other volleyball players, is a more difficult serve, not only to execute, but to pass as well. So the object of this serve is to hit it with a completely flat and firm wrist, so that there's no flick with the topspin or any difference in your point of contact. You're going to be hitting it directly straight on and hoping that it goes straight across the net and continues to travel. So this is going to be similar to a knuckleball pitch in baseball. So when the pitch is thrown, it's got this erratic and kind of unpredictable path as it moves towards the plate. Same is true for the volleyball serve. So when you hit the ball, it's not only going to be moving kind of left and right, kind of unexpected motions, but it's also unsure when it will drop or when it will carry on. So that's just the difference in the force you use to hit it, as well as if you can actually hit it straight on and there's no other variables involved. So the lack of spin causes the vortices over the seams and separate patches of the ball. So that's kind of what causes it. There's the difference when the air is coming towards the ball as it's moving through the air. It's going to be caught on the seams and the different parts of the material. And you'll see right here, this is jump serve, it's kind of the same as a topspin serve. The ball for a float serve is going to carry until it drops towards the end. Where the float, for the jump serve, it follows a more dramatic drop, and you'll see that in any type of serve when you fully see the difference. We just have an image of a baseball pitch, so you can kind of see that erratic movement is going to be the same for the float serve. Right here is kind of jerking to the right, and then you'll see it curve back in towards the left as it's coming closer to the catcher's glove. Wasn't that slow?
No,
Either, so.
yeah, so there.
Oh, there we go. So yeah, it kind of curves to the right and then to the left again, and it's uneven when it goes up and down as well. So that's the same concept for a float serve in volleyball, making it very difficult for the passer to predict where it's going to land, as well as set up their platform in order to pass an effective ball to their center. So next comes the jump serve, which this kind of involves the same concept as the vertical translation that I mentioned with the jump set as well as the crouch set. So your point of contact is going to be raised based on that vertical jump that you have at the initial point of the serve. So like I said, same concept as a set. It's an increased point of contact, so it means you can have more of a downward curve on the ball because you are in fact higher than not necessarily higher than the net, but you're higher in your points of hitting the ball. So yeah, just definitions up there too. The type of serve where the player increases the power and height of the serve by jumping, using that force during their hit.
Serving distances, as the point of contact gets closer to the net, then the height of the ball increases. So you see it goes up. So like when you're serving a short serve, you want to be closer to the line so that you can get it up and over and drop right on the other side of the net. But when you're further away, it's more of a flat curve. So then you want to be further away so that when you get it over the net, it doesn't land out of bounds and it lands in bounds because the curve isn't as up. So you have to measure that with your distance from the line. And this is from the vertical stretch, not the vertical compression.
Yeah, it's the same too. Because like with the set, how we talked about how the setter moves with their initial contact. In this case, the server's not going to move, but the point of contact in which they're aiming to get the ball in the court. So that's where the vertical, or the horizontal, I should say, the difference in length will vary. We just have a couple videos to show you the serves themselves. So that would be your short serve. You can see the point of contact on the screen, but the point of contact was closer to, well, the point of contact was closer to the net, as you can see. Next we have, I believe the float topspin serve is next. You'll see it comes closer to the height of the volleyball net itself and it travels over, so it's kind of, it starts out flat.
Has more of a dramatic drop.
Yeah, exactly, more of a dramatic drop. And then last we have our float serve. And you'll see the point in which it hits the ground is further away from the net than both of the previous. So that's both of those. Alright, next comes your angles involved with serving. Kind of, we've already mentioned them with your hand. So, like I said, with the short serve, you're going to want to hit the bottom, towards the bottom of the ball when you are making that contact point. So as you hit the bottom of the ball, it's going to cause the ball to travel upward and over the net. Topspin serve, you're going to hit the top and you're going to flick your wrist as well in order to get that extra little spinning motion. And then the float serve, you're going to want a firm platform perpendicular to your line of symmetry on the ball. So that's pretty much it for angles involved with the serving. Then we have angles involved in the blocking. So there's a lot of words on this slide, but basically it's describing the use for graphics. So this image right here is when your block is going to be directly straight on to the net. This type of block is not as effective because you're just kind of, it's up there and it's straight across from the hit. So as the ball is hit into your hands, it's going to ricochet off and kind of backtrack further, giving the opponent more time to see the ball and to react. When the ball, say, is coming from, it's the third hit of the game, and it's coming from a lower, like a pass coming over the net, you have your hands extended over. The ball is going to hit your hands and shoot directly down, giving the opponent less time to react and plan ahead. This image we have is when the serve is coming over and your hands are angled a little bit further towards the ground. So the ball is going to come, hit your hands, and directly shoot down, hoping to hit a part in, court, position on the court. So this also comes with, when you do have the right angle and you're able to extend over the net's coming right here. You're able to extend over the net, you can direct your hands with slight angles in order to get the difference in your block. So an effective blocker will be able to use this to their advantage and really direct the ball where they want it to go. The last instance we have is this fourth one, where the ball is going to hit off the net and it still carries upward because it has enough force, but your hands are still there, so it shoots down at a more severe angle. So those are your 4 different blocking kind of images that we developed.
The gravitational factors. For volleyball, there's velocity involved, which is distance divided by time. And this, before the player can attack the ball, they need to watch the set and read its trajectory, speed, and placement in order to calculate where the approach should begin and how fast or slow it needs to be. So like if it's a back set, they need to be back behind the setter, of course, and if it's Far Out 5 said they need to have more room to have a bigger approach, and they need to use the different timing methods to get it so that they hit it at the peak of the set, or the peak of, not peak of the set, the peak of where they're jumping. And velocity helps process how much time a player's approach should take, which is N, and according to the ball speed, the distance it will travel. And this helps the player achieve maximum energy and power, so we get a better,
More effective.
more effective hit.
And we have a video as well, just kind of showing you the instance where I tossed the ball out at night. They opened the net. So as I saw them toss, I had to kind of gauge the amount of approach I had necessary, whether it was going to be a long approach or short approach. In this case, it was a short approach because it was my own toss. And you had to kind of, you just base, or you follow the ball. So in my case, it was straight up serve, or set, I should say. So I didn't really have to worry about horizontal distance either. Such as.
Okay, and the way volleyball is scored is based all on probability. Obviously, you can either gain or lose the point, which means there's a 50-50 shot that you're going to gain a point on the serve. It's scored using a rally point system, which means that one team is going to get a point no matter what, whether you're serving or receiving. The game generally just goes to 25. You have to win by 2 unless it's the third game, which is a tiebreaker, and that one just goes to 15. And to find the probability that you're going to win at any given score can be shown or used with the equation that's shown right there, where the M is the current score of the first team and the N is the current of the second team. This equation shows the probability that team N is going to win at any given point. Air pressure, this generally just relates to any game that uses a ball because according to the USAV Rule 3.1, the standard air pressure of a volleyball has to be between 0.3 or 0.325 kilograms per square centimeter, or 4.26 to 4.61 psi. The more air pressure a volleyball has, the further it's going to go off contact, and the same is true for less pressure. It's not going to go as far, so the correlation is it's going to be directly proportional. And we also have 2 videos that kind of shows this.
This figure is a ball with air pressure. This is a ball without air pressure.
The coefficient of restitution is defined as the tendency of an object to return to its original shape after deformation, so basically like a bounce. The number that represents this is a number from 0 to 1, 0 being the lowest tendency to reform and 1 being the highest. So like a super ball, for example, would be closer to 1 than say a hockey puck, would be closer to 0. As the height, I don't have this on here, but as you bounce a ball and you let it bounce, generally the rebound height gets shorter and shorter. This is also defined by the coefficient because as the height of the rebound gets shorter and shorter, so does the force that's coming back down to the floor. So if you let it continually fall, the rebound height is going to keep decreasing. You can find the coefficient of restitution with this equation right there. The CR equals the square root of the rebound height divided by the initial height. And that just tells you where or about how bouncy it's going to be. And the coefficient is dependent on air pressure, outside surface of the ball, and the surface it's bounced on. The table there is showing the coefficient of restitution of the volleyball at on each of the surfaces bounced on. Pro turf is like the rubber that we have like in the oxygen. So that's obviously going to bounce higher than, say, gravel. And the connection between air pressure and the coefficient of restitution. The coefficient of a volleyball on a standard hardwood floor with like air pressure that it's supposed to have is 0.75, and the connection between the two is used or is shown with the kinetic movement theory, which basically just explains that when there's less air pressure inside of volleyball, the air molecules inside can't hit the inside surface of the ball as quickly, and so it won't put the ball in a fast enough shape to bounce, causing the bounce to not be as high. When there's a higher air pressure, the molecules are more compact, hitting the inside surface with much more power, resulting in a faster loop formation and a higher bounce. So the relationship between air pressure and the coefficient of restitution is directly proportional.
These are a list of our sources. And we'd like to thank you for listening to our presentation, and we'd like to ask if you have any questions or clarifications we can make. Kruger. Oh, yes, Spencer.
So, we noticed that your username was I Hate Life with a bunch of sixes. Is that
We
about-
found those on YouTube though. So those are videos on YouTube. I'm not sure who the. Not sure.
What did it say?
Yeah, I Hate Life. Remember?
What do you know?
Yeah.
Any other questions?
Good question. Good question.
Did you actually have
Sarah, what was the most difficult math out of all of it to like figure out or calculate?
Probably my coefficient of restitution.
Just because there's a lot of factors involved, I think, with like the differences in your surface, the differences in, the ball itself, and all sorts of variables. So we kind of had to dumb it down a little bit in order to not, be so specific because we'd be here all day. So those are pretty bad.
Well, I thought you did a really good job explaining this. My expertise in volleyball is very limited. I do have a couple of questions though. I saw one slide, mid-to-net.
That was the original name that came up with it, and then he saw them playing it, and someone said that it looked like they were volleying it back and forth, and that's where the volleyball came from.
Is there a reason why you came up with the term mid-to-net?
He just liked the name.
Okay. And then, because I know nothing about volleyball, you were talking about the setters, and you had 5, 4, 3, 31, B2, B1, 9, and slide. I'm assuming those are intentional positions that you're going to put in.
They're just different types of sets.
It's like
for different headers, like 9 would be for a right side, 5 would be for a
Do
left
you know
side.
ahead of time that's what you want to do, or?
Yeah.
I mean, does the coach say, hey, we need to do a little bit more 31s rather than
Usually
9s?
they'll just call out depending on where the pass is going, which would be easier for the
The coach does that?
The play.
Well, during a varsity game too, a lot of times they'll have, say, a free ball play.
Yeah.
So your free ball play is when the opponent passes the ball over, and it's kind of an easier ball to pass versus like the serve or a hit. So you know that your pass is generally going to be straight to your setter. So your free ball play might be 3 sets for your 3 different headers when you're up at the net. 3 sets are kind of more difficult to execute. So for most cases, it would be a 31. This would be the 4, also called a shoot because it gives the opponent less time to see, as well as a B1, which is like a 1 set backward. So it's a 1 set height, which means it comes about a foot off the net. Same with the 31, it comes up about a foot off the net. There's where the 1. Then the 3 spot, and then the 4, they just call it 4, it's not 41. It's the 4th spot across, but it's also that kind of 1 to 2 range above the net.
So, I mean, this is all, so somebody's yelling out, hey, and so you try to perform that type of.
When the ball comes over and the setter gets the ball up, like they normally have like 3 hitters going at the net, so they all call like CCC, which is like the 9, which is back, or 5 or 1 or 2, and then the setter has to then decide which one they're going to go to. So all 3 hitters have to be ready, and then the setter ultimately decides which one to set up.
They all start their approaches at the necessary time. So like the 4 set, they also they approach.
They all go to help fake out the other team too. So it's not just like always the one person posting.
So, I mean, the parent graph, I'm talking about the functional representations for those.
Checking on this slide, yes?
Well, you have a parent graph, a minus x squared.
Okay, yep.
Okay? And then you wrote down a minus, and then you have the translation of 2 to the right, translation of 2 to the left. Are those your own calculations, or are those that you saw, like this negative 0.125 x squared plus 25? Did you determine those
That
based
would-
on your graphing?
That would be based on kind of this image right here. So I didn't mention the position was between the 2 and 3 spot. So as you move, say, we just said for instance that the setter was in the 2 spot. So they moved, half a position across the net. And then when they moved 4 to the 3, it was also the same way. So it was just kind of based on that position.
So those are what you generated yourself, except to convert
Off the
that into
picture.
rows. Oh, okay, very
Yep.
good. That makes sense. And then how long has rally scoring been in effect?
That was since, do we have that date on there? I think it was
I
since,
don't know if you have the date, but it originally started where it was originally started like tennis, where one serving is the end and one gets the point,
Yep.
and then they switched it to shorten the game time, because otherwise they would be better runner.
Okay.
I think it was like that 19, it was 1994.
Yeah.
Somewhere in there.
I
So it was
just got a couple more questions. And then you had a probability diagram. When you were talking about probability. There. And that probability diagram is what generates that probability equation. Am I correct on that?
The picture is just like, if it was set up as like a tournament, these would each be a team, and then like the winner, like 50%, you'd be the winner.
Right, but it's based on the rally scoring, correct?
Yes.
So that generates that particular formula. And then I missed the PSI.
The PSI was,
I know you gave it to me in kilograms per inch. But sort of writing that down and you said PSI.